Good morning, good afternoon, or good evening. Welcome at this special Pig Progress webinar revolving around biosecurity and high-level hygiene. At Pig Progress, we are very proud to host this webinar together with CID LINES, an Ecolab company. And here in Rotterdam, in the Netherlands, it is 3 p.m. And my name is Vincent de Beek. I'm editor for Pig Progress, and I shall be your host for this webinar for the next hour or so. This webinar I will not do on my own. I will have, as you can see in the office, in the studio, I am joined by Eline Kleijs.
Hello.
And at a distance, we are joined by Dr. Carlos Pinheiro, as well as Dr. Gabi Duggan. I shall introduce all speakers in more detail a little later. As this is a live webinar, I would like you at home or in the office or at the farm to encourage you to participate in this webinar. You can ask live questions to any of the speakers. Just hover with your mouse over the screen and you'll see an orange button popping up that says ask a question. My advice would be, if you have a question, ask it straight away and do not wait until the speaker is done speaking, because then your question might arrive with me too late. And in case we do not get around to answer the questions, you will get an answer by email later on. Right, having said that, I would like to introduce the first speaker here, and he barely needs an introduction. Dr. Carlos Pinheiro is CEO of Animal Data Analytics in Spain, and he's a well-known expert in the field of biosecurity. And in his presentation, he shall focus on the question how biosecurity enhances healthier pig production and how it promotes vital animals with higher welfare, now as well as in the future. So, Dr. Pinheiro, we're very proud to have you here, and we are curious to hear your story.
Thank you very much, Vincent. So let's go for the topic. It's a very timely and trendy topic, since it's probably one of the biggest concern in the industry. It doesn't matter if you are in Southern East Asia, if you're in Europe, if you're in the Americas, but right now biosecurity and the relationship with health, and how can we manage that and improve and boost production in some cases. This is related to some diseases that could be catastrophic diseases that we know well as ASF, African swine fever. Also could be with some epidemic diseases that is related to highly pathogenic strains of PRRS, either in Spain or in other countries, but also the old friends. Normally, some of these diseases are coming together with these old friends, there's dysentery, actinobacillosis, mycoplasmosis, epidemic diarrhea, and some others. Regarding this, there's a number of projects, either private projects or either public funding projects, aiming to control and enhance biosecurity in livestock production. But this is not affecting only swine. Jumping among different species, something quite common. Flu is one of them, avian flu, swine flu. It's affecting, I would say, livestock worldwide. And lately we have seen that this is also affecting dairy, in particular in the United States, in California, where there was a good number of farms infected, over 1,000 in there. And it seems that related to an USDA a report is basically related to failures in different aspects of biosecurity, not respecting the rules of clothes changing or food changing or animal movements or whatever. Because of this, we see a good number of movements, including the investment of $1 billion to combat avian influenza, since it's something that is not only affecting livestock productions, but also the human health within the One Health concept. There's a good reference, which is the Rabobank report. In the first quarter of this year, there's a number of interesting things, as it used to be from the Rabobank reports, where they say that animal disease outbreaks keep on challenging production and the markets, in particular virus related. The pork industry keep on being reactive and investing in solutions, not only the classical ones that are there and we need to respect, but also investments in new approaches regarding technology, regarding automation, regarding digitalization. Even some forms of artificial intelligence are present, and some farms, normally related to bigger farms, are already start using this technology, sensors related for either health and biosecurity monitoring. The impact is huge, and the structure of cost sometimes is even bigger than we expect. We have a number of costs directly related with the impact, which are medical treatments or loss of productivity, growth, milk, egg, depending on the species, mortality, replacement cost, and the risk associated with that is not only buying the animals. Of course, we have to deal with more labor. The labor is increased because of this feed costs, because of well-known changes in feed efficiency, and even some others that we define as social costs regarding with public health, because some of them are zoonotic diseases that can jump to humans also, can also disrupt the supply chain, affecting food biosecurity. And based on also in some recent papers, there's even an environmental impact because of the increased CO2 emissions, because of the lack of efficiency or even mortality and some others. Last and not least, even more important, the trade restrictions. Market can be closed based on some of these diseases, and depending on the country, the insurance costs are also associated. There's a nice new calculation which has been recently published to quantify, to calculate the global burden of animal diseases, because until now we have I would say, a partial view of what is going on. I like this publication because it's published in the Lancet in Planetary Health, and they propose a new way of doing, converting the physical consequences of disease on animal performance to farm level cost. This approach is quite nice, is quite solid, and is amazing because we can go over 270,000 billions US dollars. So if we already knew that animal diseases are quite important and with a big economic impact, probably now we are even more conscious about that. There's another recent published paper that under this concept of One Health, because it's not only animal health, it's human health, and it's also environment associated. I like very much this approach. There's another wide review, a very systematic review, including a high number of countries, either high income, middle, or low income in the 5 continents, affecting not only monogastrics, pigs, of course, but also chickens and aquaculture, in a wide scope of ways of producing, intensive, experimental, and in this case, most focused on bacterial diseases. In this case, this study is giving us, under this approach of water hygiene, sanitation, and washing, which is the impact on the infection burden and antibiotic use and resistance. It's quite interesting because it's affecting everything, much more than we expected. The summary of this great work is that a good percentage of these studies inform in a positive way of these good procedures, this wash intervention, water, sanitation, and hygiene. Up to 18 of 26 reports studied reduced the infection, 37 of 71 reduced microbial loads, 4 out of 5 reported reduced antibiotic use, and 7 out of 20 even reported reduced antibiotic resistance, something that is very complicated to demonstrate. And it's particularly interesting that, of course, this is affecting the whole chain. But I would like to start from the beginning, because later on, if we don't respect the source part, the reproductive part, either in gestation or in lactation, what we're going is to send a good number of animals with a high burden of pathogens associated not only in the lactation room, but also in weaning and nursery. So this is something that we should take into account because a good start promotes strongly these benefits throughout the whole chain. I would like to remember that biosecurity normally is accepted that has three components: avoiding that the disease enters in the farm. If enters the farms, we need to avoid spreading within the farm, but also avoid infecting other farms, which is more related with biosecurity in hauling and transportation. And for this, I would like to remember the statement of the Rabobank report. We need technology. Now we have more powerful tools than ever compared to this, including some forms of automation, digitalization, including different aspects of artificial intelligence, but not, I would like to go in something in practice, something that beyond the wow effect, well, this is great, sounds great, but something that could work in the daily work of the farms. I would like to mention this gentleman. This sentence is attributed to him, which is Galileo Galilei, and I like a lot this sentence: measure what could be measured and what not, make it measurable. And I think that this is clearly an example of biosecurity. Until now, we could not measure biosecurity. It was a question of feelings. I agree 100% with this statement from Jean-Pierre Vaillancourt, one of the references in biosecurity, in how do we ensure biosecurity compliance? Because surveys are okay, they work well. It's something that we have been using and we need to keep on using, like biotech, for instance, which is a global reference. We need to keep on working on farm of audits. You see a number of green hands in there. Of course, cameras are useful regarding the different aspects that you see here. But Dr. Vaillancourt states that we need sensors. We need objective data to ensure the compliance. And I will show you some examples of these farms that are using not only big farms, but also some familiar farms, because one of the good things of technology is that if it's properly designed, can be used in every farm all over the world. In a farm, there's a number of internal movements from farrowing to weaning to quarantine to the dead stock cadavers, and we can quantify this. This has been described on about which is a number of errors regarding this. This is a very nice publication from Casio, where they describe about 44 different mistakes, average 4 errors per visit. There's a number of patterns and trends where people keep on repeating over time, and all of them are related to the lack of understanding of biosecurity principles. In many cases, the people is not understanding that well, but we are blind. We are not able to understand if they are respecting the hand washing or respecting the changing of the boots or some other things. Luckily, now we have these technologies that are helping us to understand better. For instance, we can map a farm and understand how the workers are moving inside. They are respecting the rules or not, and we can, from remote, anywhere, we can see if they are not respecting the rules, as you see on the left part of the screen, or they are respecting the rules, the green lines, or there are some insecure movements. Is something that we can see, and there's a good number of examples regarding that. Is something that is very easy. You can see that this person is doing this or that, or this team is doing this or that, and which are the routes that they are not respecting. For instance, we have seen that in PRRS infected farms, that they have a kind of a chronic disease with outbreaks and outbreaks. We have seen that they are not respecting, for instance, the visit to the dead animals storage. They have to follow a rule like, please do not go to the dead animals store until the end of the day. And sometimes they go at 9, at 10, at 11, at 12, at 2, at 3. And in many cases, the farm staff are not aware. They don't remember. They don't respect the rules, but they are not aware of doing that. Or something similar with the quarantine barn. If you visit the quarantine barn and don't respect the rules, not change your boats, your clothes, or go to a farm that is negative, you can generate a huge problems. Now we can understand better, which is how is the human behavior regarding that, and not to kill anyone, of course not. Is to train, to understand better, and work as a team. And this is, I would say, a common sense statement in terms of we need traceability on these outbreaks, and it's something that we see, I would say, in every company, in every region, and in every country. In this case, we have also some technologies regarding the visitors book. Visitors book is something that now you can digitalize. This picture that you see, something that I see in many farms or in many offices, but this is something that you can digitalize. I'm going to share an example of a company that is doing already this. In this case, is a poultry company, very well known, as you see there, and they are using this QR codes to really being able of digitalize the visits, not only that part. You see that there's a number of them that they can do just doing that way. You digitalize this, you sign in the visit. It's like when the FedEx or another company that is distributing parcels do that. And it's something that you can even connect different farms. So it's something that when technology is well designed, is very helpful, and we can understand much better a good number of things. This is also being used in practice. It's involving either persons or vehicles or whatever. And with this simple entry, me as a vet or as a technical manager or a general manager, you can see a good number of things, even using something that is very visual, understandable, etc. We are respecting the rules. This is a safe route. You have a problem here, because these heat maps are very grateful in terms of monitoring what's going on. So you can avoid a visit that is not respecting the rules. You can monitor what's going on, even operations, and plan your routes, because most of the companies, they have their own logistic platform, but they don't put health or they don't put epidemiology on that. And this is something that now they can do that way. Even more, we can. This is an example of a large company with a good number of sites that they are using systems like this, and they can highlight and detect the so-called super spreader farms. Super spreader farm is a farm that is contributed to spreading a disease because of the number of contacts, because they are close or to other farms, because they are positive or negative to certain diseases. And also, if you are able, and it's perfectly possible to connect with weather data, you can either refine the risk of a PRRS, of an avian flu, or whatever, because of the wind, because of the humidity, because of the temperature, because the risk is different in summer or in winter or whatever. So right now we have, besides of the classical tools, the water, sanitation, hygiene that we need to keep because we have seen the results, we have these recent investments in biotechnology and in artificial intelligence that are helping us a lot. So based on this, I think that the takeaways are quite straight. We can see that the burden of animal diseases is not as big as we think, is even bigger. This 270,000 billions, I was amazed when I see the calculation of these guys beyond the other problems regarding zoonosis and markets, etc. This is the first step, and it's something that we need to keep. Water, sanitation, and hygiene works. This huge study presented reduced clearly disease, microbial loads, antibiotics use, and even antibiotics resistance. Do not underestimate the risk of making errors. In many cases, People is even not aware that they are making a mistake. So we need some objective data regarding these sensors to understand who is not understanding. Is the guy, the youngest person, or is the guy that is taking care of the weekends, or is a person that is not understanding the local language? To focus on them, to train them properly, etc. Until now, they are mostly undetected, and with this combination of classical knowledge and technology, we can do it better. The human factor is in every activity, but even more in health and biosecurity, is key. We are humans and we make mistakes. We are aware. Sometimes we tell the whole truth. Sometimes we don't because we are afraid, because we did not understand, because of whatever. So always pay attention when talking about animal health and biosecurity to the human factor. And luckily, regarding this, because the world is evolving into that direction, this is affecting other sectors, and I think that the livestock industry and animal health industry can get the benefits also of this. We need reliable and robust proposals that are new tools. We have had in the last decade a good number of tools, including the PCR, the ELISA, the PRECTEC, some other technologies. Now we have new tools, digital tools, that will help us a lot to be not blind and avoid this guessing game that in many cases is health and biosecurity. And now we can put together these concepts. It's not just artificial intelligence, it's digitalization, it's data science. We have massive new databases that now can be the basis to understand better, to generate more information, so we can be proactive, we can avoid problems or react quite fast to them, or even use some forms of predictive analytics, which is a form of artificial intelligence, to detect which are the sites and the farms that are probably going to contribute with a higher risk. So with this, I hope that I have given which is a general understanding and a new approach to take care of this. And despite we are working in Spain, and we work a lot in Spain, including some other countries, but problems are too common. It doesn't matter whatever you are. So thanks for your attention, and I hope that if you may have some questions, I will be able to answer. Thanks.
Thank you very much, Dr. Pinheiro. As always, a very enlightening presentation, and I'm pleased to see that Galileo Galilei made it to the Big Progress webinar as well.
Yeah.
I have an interesting question here from the Netherlands. How do farm staff feel about being watched all over the time with sensor systems, Big Brother idea? Could you comment on that?
Yeah, it's interesting because I have the privilege of meet a number of workers or farm staff either in Asia, Europe, or in the Americas, and they all, or we all as humans, react the same. The first day, they don't like it. You're going to control me. I'm going to be punished. Later on, when we explain, this is not to kill you, this is not to punish you, we want to understand better and work better. And when they see that they work less, they are more efficient, and in some cases they get a bonus that they did not get in the past, they change totally, and they are very open. So this is something that is extremely important, because if you don't understand human nature, you can have an army of farm workers against you or working together with you. This is something really important.
It requires some managerial skills as well, I suppose, if you figure out that certain employees may have spread a certain disease, and you can tell, okay, you need to learn something or be angry with them. You need to prepare your answer well.
Yeah, in fact, what we do is try to put together artificial intelligence with human intelligence, always the same way. The more tools, the more knowledge that we are able to share or with the vet, with the general manager, with the farm staff, the better. So this is a bit tricky combination, but if you're able to put things together, it's amazingly smooth, and the benefits is something that you can see quite fast, and everyone is able to understand. In a way, it's a change in the culture of working.
I see. I have one other question here about especially very young piglets. What could be the impact of not doing a proper cleaning and disinfection, especially in that phase?
It's something that we probably have underestimated. It's something that we are aware on how important is the number of piglets and the way, but we don't pay enough attention to the health status in terms of not only the diseases that they may have, also the pathogens that they can carry. So I would strongly recommend, of course, be as good as you can in every step on the chain, but pay special attention to the reproductive part, even in particular maternities. It's something that if we do well in terms of number, weight, and as free as possible of most of the pathogens using good cleaning and disinfection protocols, is a terrific combination.
I could imagine, especially the most vulnerable animals, they need their protection. Dr. Pinheiro, thank you very much for your contribution and for answering these questions. Whilst we will move on to the second speaker, please stay with us. There might be questions coming from you for you later in the webinar, and then we might connect back to you. But for now, thank you very much.
Thank you.
Okay, thank you. And with that, we'll move on to the United States, because our second speaker is from there. Dr. Gabby Duggan is veterinarian and postdoctoral research associate at Iowa State University in the United States. And water is the key element in her presentation. She will explain how waterline biology poses a biosecurity risk, and she will address how swine water systems affect medication efficacy. She will also present evidence of the impact of waterline cleaning and disinfection on water quality. Dr. Duggan, the floor is yours.
Thank you so much for having me, and thanks for that introduction. Today I'm be discussing waterline ecology and really why we should think about it and consider it in our swine farms. I tend to think that water is a little bit of a overlooked component of swine production medicine, and so I think that we'll take it away and provide a little bit of background on why we should care about it. So first, most of the previous research that's been completed has really evaluated water quality specifically and the nutrient value of that and how it could affect growth performance and health in pigs. And oftentimes they often look at like individual qualities of water and not like the combinations of calcium and magnesium or other components, right? They're usually looking at it at an individual basis. However, through all of these research studies, it's generally widely accepted that pigs can generally tolerate a wide range of water qualities, especially older pigs, with younger pigs being more susceptible to some different water quality imbalances. And so through that research, we have some assumptions that we've kind of taken with us into, modern production medicine as well. And so we think that, as long as we're providing pigs a good water quality source, like we're providing them adequate water, we don't necessarily need to worry about, the specifics of water quality. However, I think that there's been some recent research that's maybe challenged some of these ideas and assumptions that, we've seen some differences in mortality in sows and also in nursery pigs when they're on treated water sources versus on, well water or surface water. We also know from human studies that there are pathogens in surface and groundwater sources, so from wells, and that, we can estimate, like it hasn't been performed on actual farms quite yet, on pig farms, but it, can potentially be a biosecurity risk to those water sources. We also see improvement with E. coli cases occasionally if we're cleaning water lines or shocking wells with chlorination. And improve E. coli through that. And we have expanded knowledge on biofilms, and we know that biofilms can contribute to antimicrobial resistance and the generation of antimicrobial resistance genes and the development of antimicrobial resistant bacteria. And since our water medication systems are, our water systems are medicated, this may be an area for improved antimicrobial stewardship. And so there's two primary components, two buckets that I really think that waterline ecology can affect. And the first is biosecurity, both from the water source and, because they're often not disinfected before they're consumed by the pig, and also from the water lines inside of the farms from those biofilms and the reservoirs that could be in that space. I also think that we could have some impacts to medication efficacy in this stance of, antimicrobial resistance. If we have biofilms that have antimicrobial genes and phenotypically resistant bacteria, so they're growing in the face of an antimicrobial, we may be able to, that may be shed and ingested by the pigs. And so all of this background has really kind of primed us for this question of, what is the impact? What are the impacts if we clean and disinfect water lines? And so what we did is we cleaned and disinfected water lines with CID 2000. And our research objectives were fourfold. So we had, our first objective was to estimate biofilm regrowth dynamics through standard plate counts and estimate, how much aerobic and anaerobic bacteria were growing. And we wanted to see, what are their long-term effects of this one-time application of CID 2000. We also wanted to identify biofilm composition through next generation sequencing and find out, what are the organisms that are growing in these waterline biofilms, and then also identify antimicrobial resistance genes through that. We also wanted to assess water quality, all of the different components. So, the mineral components, some of the water quality specific components like nitrates and sulfates, coliforms for the microbial components, and then also in pH. And then not only may we have antimicrobial resistance genes, but we could have phenotypic resistance or bacteria growing in the face of commonly used antimicrobials such as chlorotetracycline and lincomycin. And so we cultured bacteria from those biofilms onto plates that had those drugs and see if those organisms grew in the face of that. So for our methods, we use CID 2000 at a 1 to 128 dilution for 24 hours. And so I do want to note that this is an off-label administration of this product. So it should be dosed at a 2% for 12 to 24 hours. However, in the US market, all of our farms often have a 1 to 128 dose medication system. And so they don't have other equipment, or, it's expensive to purchase additional equipment. And so we thought that, could we potentially have an impact with the equipment that they had on their farm currently? And so this CID 2000 is a peracetic acid product. And so it descales minerals and kills and removes biofilm. And so we chose 6 wean to finish sites in central Iowa, USA, so in Midwest USA, that were all on well water sources. And we selected 10 different pre-treatment and then post-treatment sample collections. So we collected water and water line samples from each of these farms at these time points. So pre-treatment, we collected original, water lines there, and then we also applied the CID 2000, let that sit for 24 hours. We flushed it out of the system and then came back and then collected at time point 1. So that's that 24-hour mark. Then we came back 3 days later, all the way to 77 days post-treatment. And so with our samples that we collected, both water and waterline samples, we tried to be very, very clean with this. So we washed and bleached the exterior pipe and any of the tools that we were using to extract those waterline sections. And then we also had disinfected the area that we were collecting the water samples from so that we wouldn't get skewed results there. So with our results, we evaluated the waterline cleaning and disinfection event at that 0.78%. So the pre-treatment and post-treatment differences here is what you're seeing. And so we significantly did remove the biofilm even with this lower dose across the 6 sites. On an average, it was about 3.38 log reduction in biofilm counts. However, I do want to note, we did achieve some complete reductions on some of these sites, but on other sites, there were not complete reductions. And so you can see in the distribution here, we've got, higher biofilm loads pre-treatment and then lower biofilm counts after. When we assess the long-term effects of this particular application, we see that biofilms were not statistically significant between time point 0, so the pre-treatment, and day 3 post-treatment. So what that means is that biofilm essentially regrew within 3 days of that disinfection event. And then you can see that biofilms actually continued to grow, and biofilm growth peaked at day 7. After that, we tended to see, some stabilization over time still, but relatively increased after that. But really, that's consistent with what's known about biofilm regrowth dynamics. They tend to have an exponential phase, so they grow really fast, especially with all the resources in those water lines, and then they can stable out over time once those, resources are kind of spent up and the competition increases. So when we look visually, it may just inspect the water lines and say, hey, are they clean? Unfortunately, that's not really a great estimator of cleanliness, as you'll see in this graph here, in these figures. So this was the original pre-treatment, what the biofilm looked like on the inside. And then you can see at day 3, this is the same counts as what we found in the original sample. So even though visually the waterline pipes look clean, you're not able to see that biofilm, right? You can start to see the biofilm develop visually around that day 14 time point, and definitely by day 77, but it still doesn't look like it did originally. So some takeaways from this: we did have significant reductions with that 0.78%. However, I'd encourage those to follow the label instructions at 2%. Even though we didn't directly assess the 2% dose, I think we could achieve more effective reductions in biofilm counts with that higher dosing regimen. Biofilms regrew to original levels 3 days post-disinfection. So really, they're growing very rapidly. There's not a lot of long-term effects of that one-time disinfection event. And that continuous disinfection may be needed to keep those biofilms managed over time, and it's something to investigate. Biofilm loads can also be significant. So we had appreciated one of the 6 sites had up to 3.3 colony forming units, 3.3 billion colony forming units per mil. So it was quite significant how much biofilm was growing in here. And ultimately, these values are underestimated because it's limited to bacteria that we can grow. And so we're only able to grow, I think it's less than 1% of bacteria in these water lines in this kind of media. And so there could be a lot more in there. And finally, visualization of clean waterline pipes doesn't necessarily mean that there's not biofilm in there. So when we looked at water quality and the impact of CID 2000 in that one-time application, there were generally few significant differences between, the water quality parameters. We did appreciate significant differences in coliforms and water temperature, whether it was the location the water sample was taken. So we took water samples in both the rooms, and then also from the water source was the well. And then also we saw differences over time in both water temperature and then coliforms. The pH, we saw there were differences in the location and then also over time. And then total dissolved solids, we only saw differences in the location that the samples were taken. All farms had hard water, so that's an increase of calcium and magnesium concentrations. And so that doesn't necessarily mean that there's implications to the pig, that it's got hard water. But when we have water conditions that are greater than 7, so they're more basic, we tend to develop mineral scale on the inside of those water lines. And so water qualities can have an impact on osmotic diarrhea, such as increased sulfates over 1,000 parts per million and total dissolved solids over 3,000 parts per million. And so we did appreciate increased sulfates and total dissolved solids in 4 out of the 6 farms. So I wanted to focus a little bit more on the microbiological components, so the coliform analysis that we had. So as I had mentioned, there was no statistical difference between pre and post treatment with that one-time application. But you can see that there were differences between the water sample location. So this red line down here is the coliforms over time, that we had taken from those water samples on average. And then these were the averages in the rooms. And so what I want to say that this is very different, because if we're just collecting one water sample to assess on a farm and we're pulling from the well, we're missing the full picture of what the microbial components in this water is. We can also see that coliforms numerically peak at 7 days post-treatment. So again, very much mimicking the standard plate counts and the quantification of biofilm that we saw. And so in this, I think we can take this away and say, continuous disinfection may be needed to manage those coliforms and the viability of those coliforms in water, especially if those biofilms are shedding. And that water sample location matters. We need to take samples in multiple locations in order to get the full picture of what these pigs are actually drinking. And ultimately, coliforms may or may not be a problem to pigs. The research out there is currently kind of split, and there needs to be more in this space. But coliforms can serve as a pathogen livability indicator for similar organisms. So for E. coli, for instance, could be something that could grow in this condition. So some takeaways from this particular objective. So we had hard water and a basic pH. So we had, could have developed waterline mineral deposits. And really that serves as nutrients for biofilms. It helps their attachment. And then if it's really significant, it can actually reduce pipe diameter and then restrict water access to those pigs. We had elevated sulfates in total dissolved solids, which could have caused, an osmotic diarrhea in those pigs, not affecting growth performance, but still they would have diarrhea. We had, some sites, we had water quality change fairly rapidly over a period of time, likely as, subsequent to the well water being recharged with precipitation, so from a rainfall event. And so we really need to determine the best practices on when to sample those water those wells. Biofilms can degrade water quality in farms, and so we need to test in multiple locations, and coliforms can indicate livability conditions for similar types of bacterial pathogens. And we need to have continuous residual disinfection, as that one-time disinfection event wouldn't be enough to improve water quality long-term. So if we look at antimicrobial resistance over time, so these are antimicrobial resistance genes. And so this doesn't necessarily mean that the bacteria are utilizing these genes, but it means that there's tools in order for antimicrobial resistance to develop in the future or are currently happening. So we reported 3,900 antimicrobial resistance genes over 119 samples, with 4 of those being no detections of ARGs. And then uniquely, we had 184 specific unique antimicrobial resistance genes, so quite a lot of diversity within those reported. We also had 151 what are called integron integrase genes. And so these are commonly associated with multiple drug resistance. So these integron genes can carry multiple antimicrobial resistance genes and cause further spread of antimicrobial resistance. And so when we break this down by drug class, we can see that aminoglycosides were the largest component or most frequently reported. Beta-lactams like penicillin was in here, tetracyclines, phenocols, macrolides, lincosamides, streptogramins, trimethoprim, etc. And so you can see that we had associated resistance with 14 different drug classes, and some of those being both important to pigs and also to humans as well, as we don't use colistin here in the United States in swine production medicine, but we still found colistin resistance genes. When we look at pathogens and phenotypic resistance, so are these bacteria actually growing in the face of an antimicrobial, CTC or lincomycin that we apply in the water lines frequently? So we found 2 known pig pathogens. So Staphylococcus hyacus was one, and then we did find a pathogenic E. coli strain. So it was a hemolytic F18 E. coli that also had an East1 toxin and PAA adhesion gene. And we had isolated that on multiple days at one particular farm. We also found 7 opportunistic pathogens as well. So in neonatal pigs and in sows, it causes, potential septicemia, some diarrhea in some cases as well. We had organisms in normal flora as well for the respiratory, vaginal, and intestinal tract that were demonstrating phenotypic resistance. So they were growing in the face of these antimicrobials. And so we do have some NGS results still pending. So these aren't the only organisms that, we could have grown, but there's more information coming on that. So some takeaways from this antimicrobial resistance objective, antimicrobial resistance is prevalent in swine farms, and specifically in these waterline biofilms, and that we can find both pathogens and opportunistic pathogens demonstrating this phenotypic resistance. We also have the genes so that, there could potentially be more resistance if the right factors were, all aligned. And that we also had associated resistance to at least 14 different drug classes, both encoding for, to human and animal health drugs. So in project summary, water and waterline biofilms are a biosecurity risk to farms. Pathogens can be transmitted through the water source and through those biofilms, especially if you're not disinfecting between groups of pigs. Some of those organisms could be lingering between groups of pigs. If we do apply a waterline cleaning and disinfection event, biofilms can grow back within 3 days. And so we may need to consider and investigate if continuous waterline treatment would be needed and can control those long-term. And I would recommend that we need to follow the label instructions of the particular product. We also need to take water samples in multiple locations to get a really good picture of what those pigs are actually consuming as far as water quality. And swine waterline biofilms are a reservoir for both antimicrobial resistance genes and phenotypic resistance against CTC and lincomycin. And really, there's a lot more research that needs to happen in this space as far as waterline management and its impact on the health and production of pigs. But really, I think these results provide a really good foundation in order to build upon this in the future. So there's a lot of folks that want to acknowledge CID Lines and Ecolab Company for sponsoring this project and also my position. Also want to thank the Swine Medicine Education Center team who helped complete this project, and the Iowa State Veterinary Diagnostic Laboratory for their guidance and how to collect the samples and all of the testing. And so with that, if I've got any time, I'd be happy to take any questions, and thanks again for your attention.
Thank you very much, Dr. Duggan. Thank you very much for an interesting and very clear presentation. We do have quite a lot of questions for you. I'm going to shoot a couple of them at you, and I think it would be good if you could answer them concisely to be able to discuss a few. You mentioned, you mentioned continuous disinfection quite often, and you say that might be needed. Obviously, the question came in, can you give a guideline? How frequently do we need to clean and sanitize water lines, especially if we use water medications on the farms?
Yeah, that's a really great question. I think right now what I've been recommending to folks is in between groups of pigs, especially on the wean to finish side, using a one-time disinfection because it's a more potent disinfection to eliminate those biofilms, and then run the continuous disinfection once those pigs are in the farm. Because that's usually labeled so that they can, consume it for drinking water. Unfortunately, there's not a lot of guidance in this area on, when we're applying water medications. I tend to say do not run a biocide when you're applying a water medication, just because we don't have information and guidance on that. So really, there's a lot of research that needs to be needed to have better guidance in that.
Yeah.
Great question.
A question that would follow up on that. How frequently should we monitor water microbiology, or would that be different from farm to farm, perhaps?
Yeah, so it may be different from farm to farm. We definitely saw a lot of individual changes between farms, but I think, in general, I think water testing at least once a year. I would encourage, if you have the resources available, to do it more frequently than that. You could check on coliforms more frequently if you did have more resources. But again, we don't really have a great guidance, unfortunately, on how often it should happen and the implications to the pig at that point.
Excellent. And last but not least, your first sentence was that you feel that water is often an overlooked component. Why is that the case in your perspective?
Yeah, so I think that really we've had a lot of evidence that has maybe directed us otherwise. Pigs have been drinking out of rivers and streams and they've grown just fine. But I think that we are raising a completely different pig now that genetics have been improved since those studies have been completed. So I think that we need to reevaluate this and see if it is, a significant component for pigs. And I think it could be.
Fantastic. Thank you very much for your questions. Stay with us for another while because we have one more important presentation to follow. Thank you for now. And I'm going here in the studio to my neighbor here, Eline Kleijs. She's Global Technical Manager of CID LINES, an Ecolab Company, and her presentation will revolve around Swine Prime, a cleaning and disinfection program aimed at reducing mortality and medication use in the maternity and nursery periods. And obviously the contribution will explain how that will benefit pig producers. Eline, over to you.
Thank you, Vincent. Hello from my side. So I want to share some results and a description of the study that we did in collaboration with Animal Data Analytics on showing the efficacy of a complete hygiene program in swine farms, mainly in the maternities and the nurseries. So how does that look like? We did a before and after trial during the lactation and nursery period from March 2024 until November 2024. This was conducted on 4 commercial swine farms in Spain. And each of these farms had control groups and Swine Prime groups or treatment groups. We call it Swine Prime as a concept to put a complete advanced hygiene program in place to get the best results out of it. So for these control groups, we were following 2 different production cycles. And for these treatment groups, we were following 6 different treatment cycles on every farm. So that means 8 control batches in total and 24 treatment batches in total in that study. So what did we do for sampling? We sampled before the cleaning, so when the animals left the maternity or when the piglets left the nursery, we took samples of the dirty surfaces. We took samples after cleaning was done, so after the alkaline detergent was applied and rinsed, and then after the disinfection step, we took samples as well. In total, we took 192 samples, and we tested mainly for total aerobic bacteria count. Then we also kept production records. In the maternities or in the farrowing units, we were checking number of weaned piglets per litter, the mortality and the antibiotic use. And in the nursery period, we were following the mortality and the antibiotic use. So Swine Prime is a concept where we want to guarantee with an advanced hygiene program to get to a Swine Prime production or optimal production results. So here we want to show you that having a complete hygiene program that involves cleaning and disinfection of the environment and drinking water treatment, so cleaning and disinfection of drinking water systems and drinking water disinfection, is helping us to give better performance of the animals in the production cycle. So we were using 3 different products in that study. For the water hygiene part, we were using CID 2000. So it's a versatile product based on acetic acid, peracetic acid, and hydrogen peroxide to clean and disinfect drinking water systems at sanitary stop and to disinfect the drinking water during the production cycle. For the environment or the barn or the boxes of the animals, we were using an alkaline foaming detergent named Kenosan. And we really focus on the good foam capacity because it's visual, you see what you do. It gives a longer contact time, a better attachment on different types of materials and surfaces. And in that way, it can give better results. And it is more efficient to help us to reduce cleaning time, to reduce water consumption and energy as well. And then for the disinfection of the barns, we were using Virucid as a broad-spectrum disinfectant based on quaternary ammonium compounds and glutaraldehyde to have a superior efficacy in the field against as much as possible pathogens and microorganisms that we have in the swine farms, and to make sure that we have a good foaming disinfectant over there as well, because of a longer contact time, the visual aspect, so we see what we do, and to get better results in the end. So here's some of the results. So it's very important to select the proper protocols and products to get a better hygiene level and to get better biosecurity in the end. So here in that graph, you see the total bacterial counts on different surfaces in the control group on the left side, and then in different production cycles during the treatment groups or the swine prime groups. Here, the nice thing to show is that on a longer term, we can even reduce these total aerobic bacterial counts more and more. So if we just change from control to treatment, we can reduce. You see at the disinfection step, we reduce a bit more compared to the current protocol on the farm. And then in the next cycles, we even reduce more until we can almost go to 0 colony forming units per milliliter. Important detail here, the control group is using already an alkaline detergent and a disinfectant. So we compare to a current existing hygiene program on the farm. So alkaline detergents for the cleaning and disinfectants based on phenol, based on glutaraldehyde and quaternary ammonium compounds, and based on parasitic acid were used in the different commercial farms. In the swine prime group, we use Kenozan, Virucid, and the CID 2000. The water treatment products in the control group were or based on sodium hypochlorite or based on hydrogen peroxide. Then some of the results that we could collect during the maternity phase. So we could show that we can have a higher number of weaned piglets per sow. And that's quite important because at the end of the day, that's what gives more money back to the pig farmers. So we have an increase of 2% weaned piglets per sow. That means if we talk about a 1,000 sow farm, that we can have 200 extra piglets on that farm. That makes quite a big difference. We also can deliver a lower mortality, so we can reduce the mortality quite a lot with 16% in the maternity phase. So the pre-weaning mortality is reduced 16% when we apply our Swine Prime program or a complete hygiene program focusing on cleaning and disinfection in the environment and drinking water hygiene. In the nursery period, in the maternity phase, we can also reduce the antibiotic consumption. So that gives quite a big reduction as well. Like you can see in the table, the control group has quite a high medication use, so 18%. And when we apply our protocol, our Swine Prime program, then we can reduce that 4.7 times. That makes quite a big difference as well. Then when we go to the nursery period or the piglet batteries, so where we have the weaned piglets, then we can show a reduction in mortality as well. Here the reduction is about 14%, what makes quite a big difference and a significant difference as well in the nursery period. And also related to the antibiotic consumption, we can reduce 1.5 times the antibiotic use compared to the control program when we apply our program. And this is quite a big difference and significant as well. So here a small summary on the results that we could collect from that study, and that's quite unique. I think everyone is talking about that, but now we can really prove it by performing that study in collaboration with Animal Data Analytics. And when we apply an advanced hygiene program where we take into account proper cleaning with a strong alkaline foaming detergent, proper disinfection with a broad spectrum disinfectant based on quaternary ammonium compounds and glutaraldehyde, and taking care of drinking water hygiene with the CID 2000, a parasitic acid hydrogen peroxide based product, then we can get the following results in the following unit: plus 2% piglets per sow, or 200 extra piglets per 1,000 sows on the farm, a reduction of mortality that is 16% less compared to the current hygiene program on the farm, and 4.7 times less medications or antibiotics that needs to be applied. So here we really see that we have a much lower infection pressure, so we could reduce the pathogens or the microorganisms that were present in the environment by doing a proper cleaning and disinfection. And that results, of course, the lower treatment costs and the lower use of antibiotics. At the nursery unit, we can reduce the mortality with 14%, and we can reduce the antibiotic use with 1.5 times. So also here, lower infection pressure, we can reduce these pathogens much more with our protocol and products compared to the control groups. So the main takeaways from our side, a Swine Prime program or an advanced hygiene program helps to maintain a healthy and more efficient pig farming operation. So it gives a lot of benefits for the pig producers. And I think that's what we all want to share with the pig producers and where we want to focus on and to give them the right advice. So when we apply proper cleaning and disinfection, and when we take into account drinking water hygiene, we can reduce or we can prevent diseases by reducing the presence of pathogens that are causing these diseases. We can reduce antimicrobial use or treatment costs on the farm. We can reduce the mortality by having a lower infection pressure, of course, and we can improve on top of that the performance of the animals. So a better hygiene level, better biosecurity level, a lower infection pressure will give a better performance in the end as well. So here we saw in that study that we could reduce respiratory, lameness, meningitis, and some of these diarrheas as well by implementing advanced hygiene programs. So that was it from my side. I hope that was clear. Thanks for listening.
Thank you very much, Eline. An excellent presentation once again. As I understand it well, being able to demonstrate that the outcomes of these studies that you've showed, that is something that has not often been done before, I understand.
No, I think that's a study that is quite unique in the swine industry to really prove and to be able to put a value next to certain products and protocols that we put in place. Because of course, when we do cleaning and disinfection, we expect to have reduction of pathogens, we expect to have better performance. But what does it really mean? And I hope this study helps us to convince the farmer about selecting the proper products, applying the proper protocols, and that it helps them, that it gives them a value or a return on investment.
Mm-hmm. I see. And if we now look back to the whole webinar, and we've listened to Dr. Pinheiro's presentation and to Dr. Duggan's presentation, obviously these programs make much more sense if biosecurity is top of mind, because if the rest is not being followed through well, then biosecurity as a cleaning and disinfection may not have much sense. But if you can summarize this whole package, how important do you think that a cleaning and disinfection program is in the whole of biosecurity programs?
Yeah, so biosecurity is much broader than just cleaning and disinfection, water hygiene. These are all components of a complete program. But I'm convinced that biosecurity should be the basis of every disease program on a farm. And cleaning and disinfection is part of it, water hygiene is part of it. And if we want to improve that biosecurity level, we need to take care of cleaning and disinfection and water hygiene.
True. And then kind of the whole package will help farmers get better.
Yeah, because if we just spend money or put efforts on cleaning and disinfection, but we forget about the water hygiene, then we saw from Dr. Duggan's presentation that we can still have infection pressure via the drinking water, but the other way around as well. If we take care of drinking water hygiene, but we don't do a proper cleaning and disinfection, we will miss some pathogens over there as well. Yeah,
and that all comes down to the human behavior as well, as Dr. Pinheiro said.
For sure.
It's a mindset thing as well. Well, thank you. Wise words to close off. Thank you very much. I think looking at the clock, that is more or less time to draw things to an end. But before I let you go, I have 3 last points. In case you wished to review this webinar, or in case you wish to recommend it to somebody else, just go to www.pigprogress.net and navigate to webinars in the top navigation. There you will be able to find this webinar and view it back again at no charge whatsoever. Secondly, I'd like to point your attention briefly to a webinar of my colleagues at Poultry World. They will be back here in the studio on May the 8th with a webinar focusing on the 2025 Respiratory Integrity Forum. And last but not least, I'd like to draw your attention to a little survey that you will be asked to fill out straight after the end of this webinar. And your answers will help us to improve the quality of future webinars. And with that, I will let you go. I would like to thank Dr. Pinheiro, Dr. Duggan, as well as Eileen here in the studio for their excellent presentations. I would like to thank you back home in the farm or in the office for staying with us this hour, and I hope to see you again very soon. Thank you very much. Bye-bye.